many people's real cost isn't in the part. It's in the stuff associated in processing that part, holding it, packing it, and handling it. And that's where you're going to save your money.
Hello and welcome to the MTDCNC Podcast. My guest today is Ian Weston, the Managing Director of Markforged UK, and my name is Joe Reynolds, the host of today's podcast. Ian, a very warm welcome to the podcast. How are you?
I'm fine, thank you, Joe. How are you?
Yeah, really good, thank you. Yeah, thank you so much for coming on. Just to start with, can you tell me a little bit about Markforged and your partners, Markforged, please?
Yes, of course, yeah. Markforged set up back in 2018 to supply into the UK market the Markforged range of plastic composite and metal printers. And we're what's known as a soulless reseller. So we carry one brand and we specialise in their product range, which we believe has a lot of benefits for people. When they decide they need a Markforged machine, we're effectively there to help them.
Absolutely. And how do you find the market at the moment for 3D printing and additive? And just to quantify that, when I say 3D printing, I'm talking about plastics. And when I say additive manufacturing, I'm talking about metals in this case.
Yeah, the plastics, or as we call it, polymer, because our plastic is a blend of nylon and carbon fibre. Our plastics stroke polymer market is very busy at the moment. Quite a number of units getting shipped. What we're actually finding is that people are now they buy a first printer that prints the whole range of materials, including the composites, and then they add capacity quite quickly. So very often we're finding people dipping their toe in the water with an entry-level printer, and then in 3 to 6 months they're keen to invest further, which is lovely.
Yeah, and how about the markets? It used to be rapid prototyping machines, didn't they, back in the day? But it's fair to say it's matured a lot into pretty much every sector. But are you seeing any trends at the moment?
Yeah, it's a very interesting question. What we've actually found is that we used to be found in the design office, or the DO as it was known, making prototype parts for fit and function. The nice thing with the Markforged product range is that there's some good quality hardware, some really good materials, and some nice software to drive it. So now the parts can also be functional. So they can actually be, well, there's 5 Fs: form, fit, function, and then fix and forget are the two that have really started driving the market. There are plastic printed parts running car production lines in the UK that are mission critical. It's wonderful, really.
Yeah, and when we talk about plastics, it just used to be straightforward plastics, but now I'm blown away by the amount of materials. Certainly Markforged offer some plastic materials, onyx and other ones, that they're stronger than aluminium potentially.
Yes, that's right. Yes, we have a range of composite printers that allow you to print a plastic material as a surround, as something to hold a composite fibre in place. So, for example, we can make parts that are outperforming aluminium in X and Y. It's wonderful, really. An example would be there are people in Holland. We're part of a group. We've got Markforged Germany and Markforged Benelux and other countries. There are people in Holland picking up class combine harvesters with 3D printed chain links, one in each corner. It's just incredible.
That is astonishing, isn't it? It takes a lot of trust, but these materials, they are structurally very, very strong indeed, and there's other benefits as well. I know you've got a fire retardant, if that's the correct term, retardant material.
Yeah. So what we're actually seeing now is there are a range of materials that Markforged have developed which allow you to make end-use parts for aircraft, and they can go up and fly in the air. The rough rule of thumb, although there are some certain anomalies, but not many, if it touches your skin or it goes in a train or a plane or a spacecraft, it needs to be flame retardant. So basically, if there's a naked flame put against it, it won't drip and burn. It won't ignite. So there's that one, and there's an anti-static material too. For if let's say you're making satellites and you want to do some very intricate work on PCB boards, you can't get static anywhere near them. You'd use this ESD, electrostatic dissipative material, so it doesn't carry charge, which is lovely.
Yeah, and if we look at the metallics, your world leading Metalex additive manufacturing machine and full process. How's that looking now? I know you've got some tool steels. You've even got some heat resistant alloys such as Inconel, and that blows my mind, to be honest. How you can print Inconel, knowing how difficult it is to machine. It's astonishing, really.
It's incredible, isn't it? We always say to people that people should learn on polymers first. They should buy an entry-level plastic or polymer machine and learn all about 3D printing. When they've done that, many people are now starting to look at metal. The plastic has come full cycle, so they're back to looking at their first investment in a metal printer. And Markforged have been very clever. They've completely de-skilled the use of these machines and made it so that somebody like myself can get a metal part out within a matter of a couple of days. There's no powder. It's all of the material is held in a spool. So it comes off a spool in a filament, and it's held together with a wax and a polymer, which disappear when we put the parts into the furnace. It's incredible.
And that's the big advantage for Markforged technology, isn't it? You don't have to have big coats with respiratory equipment. You don't have to take a day potentially to switch from one material to the next. You can go from H13 tool steel to Inconel in maybe half an hour?
Yes. If you want to take that long about it, Joe, yes. But the nice thing about it is that you're right. You don't dress like a beekeeper. There's no metal particles flying around your plant, contaminating stuff. You can change materials quickly. But the real thing is that I've seen a lot of people that have got finishing benches with angle grinders and dezooters, getting support material out from the machines that have made the part, cutting out supports for overhangs and things. The lovely thing Markforged have done is they've made sure the supports break away with your hand, or at worst a tap from a copper hammer, and they break away. So there's very little effort in getting a finished part out. It's lovely.
Sure. And the two things that have come, you used the term full circle, and it's one I like to use myself. And there's two things with this. Are you going to 3D print something that's already made in large volume? There's a good chance you're not. We're looking at, we've got to get designers to design there's been a lot of restrictions when you're designing a product, and you have to design it because you need to mill it, for instance. Whereas with this now, you can honeycomb, you can put a hole around a corner, which you can't EDM, you certainly can't drill. So really, it's getting into the designer's heads. Actually make what you want, not what you used to be able to manufacture.
Correct. And as a youngster, they used to love saying to me at Rover, great design, but you'll never make that, son. Or you'll need to split that into 3 parts to get it to manufacture. Nowadays, makers are everywhere. We don't see these restrictions. So the best engineers could design something and they knew how to make it at the same time. Nowadays, complexity is for free. It's wonderful.
Yeah, that's a term I've heard you use before, and it does certainly resonate, doesn't it? The printer doesn't mind how difficult the component is. And just on that, another what I would call as a soft barrier to entry used to be how you program these darn things. It would, you'd be worried about the orientation of the component, how many I can get onto a bed. Whereas I've seen the Markforged software, and it is. Well, it's not programming. I'm not doing the people that run these an injustice, but it's not programming, really, is it? It's very straightforward.
No, you're right. The piece of software you're talking about is called Eiger, and it comes with every printer. Markforged have written it to suit their printers, and with the quality of the hardware, with the materials that are quality checked, and this piece of software, life's very easy for the engineer. 3D printing is now reliable and repeatable, and very, very easy to use. It's only simply a matter of putting the part on the bed, choosing your materials and your infill and your thickness of your shell around the outside, and off you go. It does it all for you. Writes all the printer code and everything. Yeah.
Yeah, and you're making that sound simple, but I have seen it in action. It really, really is that simple. But if we move on to your recent campaign with Ambar, you've embarked and you've brought us along for the journey, which is great, on a campaign for CNC machine shops. Yeah. It's named 15 Reasons to Have a 3D Printer in a CNC Machine Shop. It kind of says what it is on the tin, but maybe if we could just quickly run through some of these reasons, that would be great.
Yeah. So this campaign that we're doing at the moment now is actually trying to explain, and we will explain via white papers or some of the videos we've done with you, or indeed we'll go on site and take printers to help people understand the benefits of adding a printer to a CNC shop. Now, one of our customers, Goering, who we all know and love, saw very early on, they didn't see additive technology as a competitor. They saw it as something to make their products and process better. So they embraced additive, although their whole livelihood depends on subtractive. So our take on this is, don't think about replacing, think about complementing the stuff you've got in your workshop with a printer, because there's no doubts about it. There are thousands of companies that are tying up expensive bits of kit, making things that should be and could be 3D printed.
I couldn't agree more. We're starting to see more of these, in truth, but not enough. Certainly for fixture manufacturers and things like that. I think it's essential. But if we go through some of these reasons, maybe let's start with I don't know. Like I just said, jigs and fixtures. That's a good place to start.
Yes, very often when we're working with companies, it isn't actually the machining or the actual subtractive process that takes the time. What we see is that the lead times are very often down to you need to be able to fixture or hold your part for things like coordinate measuring machines or laser marking or other downstream processes. And we've got one example of a customer that would print a fixture in a day or two, or something to help on the production line in a day or two, and then it would go down to inspection, and they'd take a week because they'd have to put it in the queue to do the job. And it's very much the same with the internal engineering effort. You have to get in the queue to get your fixtures made to hold the part you need to ship. So what we're saying is that we should be using 3D printers to do that. Soft jaws are wonderful. Robot grippers are great places to look at. Inspection departments love 3D printers because they can just dream up all these weird and wonderful ways of holding items to check. And the nice thing with the Markforged product, it's a very accurate print, so that we actually get a nice tight fit with our component. We don't get something that's close but wobbles. You click it into place and it sits there and it's done.
Like you've said, these parts are going on, some pretty well-known cars, aren't they? So it's clearly the holding tolerance and all the other things. But yeah, if we can move on to some of the other benefits, I'll be led by you really. What do you think? What do you think are some of the other best benefits?
There's a lot of them. Some are really soft. For example, the power consumption, it uses about the same as a 100-watt light bulb. There's no 3-phase needed for it. You can plug it into a 240-volt socket. Maybe you can hear in the background, I'm sat in a room with printers running now. Very quiet. You can go about your daily work. It's in the corner of the office. It is, in fact, somebody in your office on a milling machine for nothing. There's no tooling costs. So because I've got a special size hole, something I haven't got a drill or a reamer for, it doesn't matter to a printer. There's no tools. And you just think, crumbs. Yeah, that's an obvious one. There's no waste. And no waste from swarf.
That's a big one in the in the current world, isn't it? We're all looking to reduce our carbon footprint, and that's only going to get, I say worse, that's not the right term, is it? It's only going to become more and more important. We're going to continue to try and improve our green credentials, use less electric, use more renewable.
There is another one with green credentials, of course, which is, and some people haven't thought of this one too. You don't actually have to be where the printer is to print to it. So, for example, if I was centrally located in the UK, but I had got distribution or maintenance facilities in, let's say, Dubai, I can print from the UK to a printer in Dubai. I can sit here using the software and say, I want to print to that printer that's in the hangar, this tool to take that engine out of that Cessna, and off I go. The lovely thing about that is there's no shipping costs, no import duties, no paperwork, it's just, I control the quality. The list is endless on that one. But of course, that's a big reduction in carbon footprint too.
Sure, and that's something that's been happening probably longer than people realise. I know a lot of these printers are dropped into war zones now, aren't they? So and that's exactly it. You're not sat there with your laptop in the war zone, are you? I imagine it's a quick email to somebody in the UK and it's printed locally.
Yes, absolutely. The nice thing about it is, if you do set up, let's imagine we've got ourselves a shipping container or something similar, and we're out somewhere in the desert printing something. All the person that's there has to do is to put the bed on the printer. A very simple prep. And the printer's ready to go. That operator or operative can walk off and just come back in 8 hours when it's finished. They don't have to stand and watch it. So there's no operator costs with 3D printing at all. So.
Yeah, no, I'm just listening. It's absolutely. The more we talk about this, and I know we've spoke about it off camera or off microphone. It's compelling, isn't it? And some of these, some people listening to that might think, that's a soft benefit. But if you are a CNC machine shop, if you're making jigs and fixtures for your CMM, if you're doing chuck jaws, if you're doing certainly vice jaws, it's becoming compelling now, isn't it? Not only for the reasons we've discussed. We haven't even talked about cost. Presumably. Let's say, what would I put you on the spot? What would it cost to print 2 vice jaws, against 2 soft jaws? Obviously, you've got to buy your soft jaws, your machining times 45, 50, 60 pounds an hour. You've got to, basically, your machine's costing you money for that period of time rather than making you money. Whereas if you're printing it, it's obviously straight into production.
You're there. Yeah, you're absolutely right. So the first thing we see is that we often see an argument between a production engineer and a production manager. The production engineer wants the CNC machine to make the jigs, fixturing and work holding for the next lot of work that he's scheduled to go through. The production manager says, you can't have it. I need to finish this batch first. And backwards and forwards they go. So in the end, the MD gets sick and tired of it and buys the production engineer a decent quality Markforged printer. What they're then able to do is they're able to take the component. In this case, let's think of a fuel injector or something that's going to get machined. That would be a cast shape to start with and then perhaps machined, finished, a thread or a sealing face somewhere for an O-ring or something. The soft jaws for us, when we make them, they cost about £8 per side to print.
So it's going to be cheaper, isn't it? It's going to be cheaper. It's going to be quicker. When I say quicker, the process may take longer, but you can press it at 6 o'clock and it's ready in the morning.
It is. It's sometimes people compare it as the tortoise and the hare. Once you've programmed a CNC machine tool, it's going to be quicker than a printer. But for us, it's about elapsed time from start to finish on the project. And the thing that's really nice for us is that we're actually starting to see customers that have got these printers in CNC shops offering new services to existing customers too. So they can before they go and make anything, very often they'll send them a plastic printed example of the component and the customer can feel it. It's tactile. So they can actually try and fit it and do things. And then, yes, they can order the batch knowing there's no change. Because the worst thing in the world is ordering 100 off and not being able to use 99 of them because the first one didn't fit.
Yeah, and to be honest, when I look at these applications, you just said something I'm seeing more and more. So people are sending a printed component to along, accompanying the quotation for fit and function purposes. And let's be honest, probably 50% of 50% of the times it's probably a bit of marketing from the engineer, the manufacturer. But the other 50% of the time, you can put the component. Maybe it's an assembly. Maybe it's maybe you're putting it on an old classic car or something like that. 50% of the time, you are going to try it and make design changes. So, yes. So basically, you can work with the supply chain, can't you? And the other one I see a lot of is in the metrology world. And when I say that, jigs and fixtures, that's quite common now to print those. But what I'm seeing increasingly is actually printing a component, an end-use component, to get your CMM program made up. There's nothing worse than spending, 2, 3, 4 hours programming a mill. And then you've got to spend a couple of hours doing it. You're basically in a big queue, aren't you? Whereas if you've got a printed variant, you could that program can be sat waiting for those parts.
That's a great example. There is a customer of ours, a medical company, and when we went tumbling into lockdown, the foundry making the hip joints for them, they were just about to issue a new casting. They just stopped, but these guys still had a deadline to get it to market. So what they did, they printed the part, the shape, the size and shape exactly of the casting. They then machined that printed part to give them first op. Then they made the fixtures for that. Then second op made the fixtures. Then they went to the laser marking and worked the fixturing out for that. And then they went to the CMM and did the fixturing with one component they'd processed as if it were steel. When the parts came from the foundry about 3 months later, they went straight through from start to finish without a problem. Incredible.
Yeah, that's fascinating. And again, another compelling reason. We are running out of time, Ian. Is there any other reasons you want to mention before we wrap up? Yeah.
There's a couple. We've already said that the footprint's pretty minimal. You can, if you want to, take it with you. They're really cheap to run. But I think the best way to sum it up for me is for less than the cost of a small van a month, you can be printing jigs, fixtures, work holding, spares for machines that are in your place, that hard to get handle, all sorts of things, customer samples. You can do all of this and take away a whole load of pain. Many people's real cost isn't in the part. It's in the stuff associated in processing that part, holding it and packing it and handling it. And that's where you're going to save your money.
Yeah, and I will say that your campaign's 15 reasons. I think you've missed the most important one off. It should be 16 reasons. And the most important one is jolly good fun, and you can make lots of fun things around the house. And
yes, you can. Don't tell anyone I'm just about to print a weather vane, but there you go.
Marvelous. Ian, thank you so much for joining us. I know you're a busy man, and thank you for it's been an education on 3D printing or additive, call it what you will. Appreciate your time. So we will see you soon. Thank you for listening to the MTD podcast. If you want to learn any more, Ian's easy to find at Mark 3D. Please do reach out to the guys there. They have got some knowledgeable experts. Thank you for listening, and we'll see you next week.
Thanks for listening to the MTD podcast. If you found value in this episode, please subscribe and leave a rating and review. Find more episodes on MTDCNC.com.